Hello everyone. Today I'm going to talk about problem set 5, which I believe many of you have been struggling with. So let's get started. And just to let you know, I will only talk about question 1, which is the option question, and the very difficult question 3. And for question 2, it's more like an open-ended question. So I don't expect any standard answers, and most of you, if you see your score, which I will post soon, if it's low, it's not because of question 2, it's more because of question 1 and question 3. So yeah, I respect your discussions for the open-ended question, so I'm not very strict on that one. Okay, let's get started. So question 1 is a option model, so like binomial tree valuation model. So professor have already given the example Excel under module 6, which is called real option, I believe. And it's just change the number and maybe do a little bit extra work because there is another option, which is the seller shares the profit, but it's basically the same Excel that I'm gonna use, or you should use. One thing is I find some of you use the put option binomial tree, which is wrong because this is a build or not build option, and the strike price is 1.54 million. This is a strike price, and if you build it, you will get something like, oh, I'm sorry, the strike price is 1.6 million, and the profit, the sale price starts with 1.54 million, which is the similar as the starting point of the stock price. And it's like, the reason it's call option is because when you choose to build it, you're earning something, you're earning more if the price goes higher. For the put option, it's more like you want to sell. So the lower the price is, the better it is for you. So in other words, if the price goes to 0, then put option actually worth the most. But for a call option, you always want the sale price to go as higher as possible. So for those who used the put option pricing binomial tree, you should know that it's completely off the track. Okay, let's get started. So this is question 3. So yeah, I'm sharing the question 1, the binomial tree that I built. I think you can see it. So I literally just changed the number that I downloaded the Excel from the Carmen, and I changed the number. So sigma is 10.8%, which is as given, and risk-free rate is 0.5%. I'm using everything denoted in million, so strike price is 1.6 million. Maybe it's a little bit too small. Let me increase the font. So the strike price is 1.6 million, and these numbers are just automatically calculated. And the asset tree is the tree of the sale price. So before the submission, I got really many emails asking me, oh, what is the starting point of the asset tree? Remember, the construction cost is the strike price. So strike price is in the call option is something that you pay as the cost. The sale price started with 1.54 million, which is here. So it goes up and down, literally exactly the same. I didn't change any of this any of the numbers here. I just put it here, and everything else is automatically generated from the Excel that Zahi uploaded. And the value of the option as a result is also automatically calculated. So really just to change the number. And you can see it will the option value will be positive if the sale price goes up and discount all the way back. So regarding the first question, it's asking which one is better compared to the two alternatives. Let's say the alternative one. Alternative one is you hold this option and you'll pay 50,000 in cash today. So the NPV equals to PV of option minus investment. In other words, in alternative one, this is PV of the option is 0.12 million minus it's 500, let me see. Yeah, 50,000 in cash, which is 0.05 million, right? Equals to so the alternative one NPV is 0.07 million. That's it, very simple, just NPV calculation. Alternative two, like this. So you can see the price, the binomial tree of the price is it's the same. But when you exercise the option, your payoff would be changed. So in other words, this last column is changed because the owner, I think the seller, will share 5% of your profit, of your like, you can treat it as 5% of your sale price. So in other words, rather than here, it is just this F9 cell minus the strike price. Here it is, I'm sorry, this is F28, which is the sale price, times 95%, which is how much you get. 5% goes to some other people, and you get 95% of the original sale price. But because the seller does not share the cost, which is stated clear in the question, so it's still minus the same strike price, which is the cost. That's how the last column is changed. This one is the same. There is a 95%. And this one, the same, 95%. So so in the question it says something like I remember it says somewhere that you can choose to build anytime. Yeah, you can build on the land anytime within the next 4 years. So actually the 95% I just did in the Excel takes into account this kind of this situation. So because the last period payoff is discounted back each period. So like this time t equals to 3, the numbers are coming from t equals to 4. So because if I multiply 95% on the last period payoff, it will always be there when you discount everything back to time 0. So this one is lower than the scenario alternative one because your final payoff is systematic, or like every cell is lower than the alternative one. So when you discount it back, every cell in the middle gets a discount. It's not exactly 95% because it's discounted by some discount factor or risk-free rate, but everything is affected. So in other words, in this alternative two, it still equals to the present value of the option minus investment. But in that case, alternative two lowers the present value of option. As you can see, it only becomes 0.9 million or 0.09 million, but it does not have initial investment. So the NPV is just a 0.09 million. That's it. So by comparing NPV, alternative 2 is better because it gives you a higher NPV. In other words, paying 0.05 or $50,000 today is too expensive. You should, I mean, rather than doing that, you might sharing some profits, which discounted back to from future to today actually is more cheaper. So yeah, that's question 1. And question A. In question B, you ultimately decide to pay this in cash today and build over the next 4 years. 1 year later, the market goes up. You could now exercise your option to build for 1.6 million, which is the same cost, and sell it for 1.7 million. Should you do this? So the standard answer would be compare the NPV. So 1 year later, if you build for 1.6 million and sell for 1.7 million, what do you get? You get 0.1 million, right? So like $100,000. However, if you look at your option, it's basically this scenario. And if you look at your option, at T times 1, price goes up, which means you're in this cell J12. So your option actually worth 0.21 million, which means compared to the 0.1 million, this is much higher. So I know you already paid 50,000 cash earlier, but that's like your sunk cost. You should think about the value of your option now without taking into account the sunk cost that occurred in the history. So you think about, okay, now the value of my option is 0.21 million, but if I just build it now rather than wait, I only get 0.1 million immediately. So the value is lower. According to this NPV method, you should not build because holding the call option, which means waiting for the future, is actually more profitable. This ends the question 1. So now let's skip question 2 and directly go to question 3. I know this is a very hard one, and I see many of you are trying hard to do this. But one a little bit disappointing thing is I saw many people submit exactly the same answer, which is, I think it's wrong. So I've seen like exactly same wrong answer many times from many people, and I don't want to track who is the originator, but just, yeah, if you want to do that, I have nothing to comment, but still, let's talk about this question. So it has a lot of information, and I will still just show you the Excel and to show the framework of doing this, and you can find how the information is fit into the Excel. Here it is. The price of the property is 4.9 million, which is here at the end. Yes, the price is 4.9 million. And some of you asked me where to start, and my answer is you have to start with the numbers that you need to simulate at the beginning. And there are some numbers that comes from like your simulation numbers, which I will explain later. But to start, here are the things that I need as the first layer of simulation. So this column simulates the CPI, and this column simulates the 10-year treasury rate. This column simulates the spread, which is just the similar to the AAA 10-year that rate change. And yeah, this is spread. So spread comes from some other two components that I will explain later. And after get the spread, I get the cap rate, which is just a cap rate equals to spread plus the 10-year treasury. So this is exogenously simulated. The number just directly come from data. And for other things like rent and NOI, and maybe those total cash flow are coming like derived from other numbers that I already simulated. So let's see, let's get started. In sheet 2, in this sheet, I collect all the time series at annual frequency from Fred. So you can see this is the CPI AU CSL, and this is the change, percentage change. So another thing I need to clarify is, as we mentioned in class, there are two ways to do this. You can either simulate the level, which is just, for example, for CPI, you just take a number here, right? But that one is sometimes problematic because it doesn't have any more correlation between numbers, time series correlation. So to make it more realistic, a better way, which is to simulate the change, which is randomly draw from the change of CPI rather than directly from CPI level. So I'm following this procedure, but I also accept answers that simulated from the level. Okay, so let's keep doing. And the AAA is directly from Fred, which starts from 1983. And still, this is the change in AAA 10-year. It's just a simple change, like minus change. And this is a lag change. So this one just equals to a year before. I mean, either is fine. It doesn't matter. So this one is the, I think it's the treasury rate, yes. So for this one, DGS10 is still directly from the Fred, and this is the change. So for every series I get from Fred, I also create a change column. And this is another one, the Columbus local CPI. So, and this is the change. So in the first layer of simulation, what do I do? This column is a randomized, so this year, I model from year 0 to year 11. Year 11 is more like getting the NOI in 11. But this is the year in the following 10 years. And the row 3 is randomized from 26 to 63. What does it mean? Where does these two numbers come from? It comes from the data sheet. So basically, I want to get a number from row 26 to row 63. So, I mean, actually, to make it even more strict, because so the reason I don't start from column 2 or row 2 is because there are many missing data here. You can see the AAA does not exist here. So I want to simulate where there are always data. There's always a data. So actually 26 to 63 is not very strictly perfect because in row 63 it's not, there are no numbers at the back, but I'm using this CPI, so which is fine. But it doesn't change a lot of the result. So yeah. And in the homework, it gives you some example of generated random variables that captures the year you draw. So it's exactly the same. So you can also randomize a year. For example, if you get 1999, you get this row and you get the numbers from here. It's also fine. For me, 1999 is just equal to 41. So I just, from row 26 to row 63, I draw a number and I get the data from this row. So, okay, so this is the rows that I want to draw in this example. And all right, so I misremember, it uses Columbus CPI. So yeah, I should have changed it, for example, here to 62. Doesn't change a lot the result. So CPI always start from 100, or you can say it's like 100 you can say that 1 or something, just some unit number, it doesn't matter. So in column 2, it is previous period, or T times 0 CPI times 1 plus this data sheet J, and E3 is this one, 42. So what this one does is, in year one CPI simulated is year 0 CPI times 1 plus J42. So let's go to what is J42. This is J, this is 42. So I get the 42 growth rate of JPI, because column J is the growth, or the change of the CPI. So I use it as, so this whole thing here is the growth rate I simulate. So year 1 is just the year 0 times 1 plus the growth rate. And I do it, this growth rate is from F3, is from row 53, which is here. Row 53, still column J here. And this is the same. So in other words, I just based on the previous period times 1 plus some growth rate. Growth rate is column J in data sheet, and the row is from here, the randomized number. And similarly, for the treasury change, the starting point is 1.53%, which is given here. Let me see where it is. Yeah, so it's 10-year treasury constant maturity rate. Its current value is 1.53%. And I also model the change. This is because it's bounded by 50%, 0.5% as here. Assume the treasury rate cannot decline below. Yeah, so because it's bounded, so there is a maximum between 0.5% and this whole thing. So still, the point is here, this whole thing is the previous period 10-year treasury rate plus the change. The change comes from column H in the data sheet. And here I want to get the row 32. And that one is in percentile, so it has to be divided by 100. Let's check if column H is for the change in treasury rate. Yes, column H is DGS10. So this one is the change in treasury rate. And it's in percentile, so percentage, so you have to divide it by 100. So still everything here is it's simulated based on previous period. That's it. So I will not explain like future ones, just yeah, spread start with this one. This is spread, the starting point. And it follows still from last period plus the E column. E column is the change in the AAA 10-year rate. This models the change in spread. And after you get the spread, column is very easy. Column is just the 10-year treasury plus the spread. It's the same. So it starts with 5.45%. That's it. This is to model the CPI simulation over the next 10 years, model the 10-year treasury rate, model the spread, and model the cap rate. And let's see the rent NOI part. So the starting point of your unit, like occupied unit, is 23, which is given here. Yes, in bullet 6. So since the price is 4.9 million, cap rate is this one, and 23 units are rented. NOI per unit is 11,000 something. This is the starting point. So rent evolves with CPI. So this one equals to last period rent times growth of CPI, which is period 1 CPI divided by period 0 CPI. Here is the same. Last period rent times the growth of CPI. So this one models the rent. In other words, rent per unit will grow with CPI as the same rate. NOI would be much easier. So NOI is just the occupancy times the unit rent per unit. And occupancy is like, it's bounded by 17 and 24, and each period goes up or down by 1 unit. And this one, NOI roll, just is the simulation of future total NOI. Exit cap rate is the cap rate in year 10. So the price plus the total cost is the price times plus the 3% transaction cost, which is given here. Bullet 1, there is a 3% transaction cost. And total, yeah, because in time 0 is just you're paying the total price and the cost. And your total cash flow would be time 0 is just the payment, the price and the transaction cost. And then from year 1 all the way to year 9 is just your NOI because you don't have any transaction behavior. And in year 10, it's the year 10 NOI plus the sale price. So what is your sale price? Your sale price will be year 11 NOI divided by your exit cap rate, which is the year 10 cap rate. So your total cash flow, let's look at this rule, includes 2 parts. One is the transaction behavior, one is the NOI behavior. So in year 1, you only have the buying behavior, which is outflow of around $5 million. And from year 1 to year 9, you just collect the total NOI, whatever it is. So it's equals to the NOI rule. And in year 10, which is the last year, you will sell it at some price comes from the NOI in 11 and also exit cap rate, which is the cap rate in year 10, plus that period NOI altogether. So this is your total cash flow. And from using this, you can get your ARR. ARR is just the ARR on this rule. And you also need a fragment, a section that models the mortgage amortization table. So let's see. It says in bullet 3, you finance a transaction using a non-source 4 million loan at 4.5% interest rate. It requires a principal repayment of 60,000 in the first 5 years, and then 130,000 for the remaining period. The remaining period balance is due in 10 years. The interest paid is based on your beginning balance. So here it is. At this row is your beginning balance. At time 0, you have 4 million outstanding. Interest rate is 4.5%. And year 1 to year 5, every year you'll pay $60,000 on your principal. So this is the principal payment rule, right? And for remaining period, you'll pay 130,000, excluding the last one, because year 10 is the last period, is the end of your your mortgage. So in year 10, it's like everything, all the remaining balance. So in other words, you're paying 130,000 from year 6 to year 9. And you can see this one, the remaining balance is just the last period balance minus your balance principal payment. It's just the same. And until year 10, you have to pay this whole thing. So year 10 is just I'm sorry. So year 10 is just the remaining balance, which is the beginning balance in year 9. And your interest would be based on the beginning balance. So for example, in year 1, it's just before you repay the principal, your beginning balance is 4 million. So it's times the 4.5% interest rate. And in year 2, before you repay the principal, the remaining balance is as 3.940, 3.9 million something times the 4.5 interest. So this row tells you the interest payment. Your total payment to the bank would be summation of these two, because each period you pay some portion of the principal and you pay some interest. As a result, again, this IRR we just calculated is the asset level or the project level IRR. So as an equity investor, so as the investor, you are having leverage. You get a mortgage from the bank, which is $4 million. So in other words, you don't need to pay this like 5 million something. You only pay the remaining residual. So this is your, as an investor, equity holder, this is your initial payment, which is basically the difference between the 5 million and also the mortgage outstanding. And each period, your net cash flow is your total cash flow minus these two payments to the bank, interest and principal. Each period is the same. In year 10, it's slightly different, but it's just your sale price plus last period NOI minus your final like paying back all the remaining balance and also paying back the interest in this period. So this row is the net cash flow to the equity investor, equity holder. And you can get the IRR, which is using this net cash flow row on your equity. So now just you can see here is the table. On the simulation. So basically, I will not repeat how to do that. I believe many of you already know. Professor covered in class. So this IRR is just the asset level IRR equals to C17. And the equity IRR is just this IRR equity, C24. And loss, what is loss? Loss means if you sell it, your sale price is lower than minus this thing. So like if your sale price is lower than your total initial payment at time 0. So because this is negative, so you have to put a negative sign here. And the IRR equal smaller than 0 is whether this asset IRR smaller than, it's 5%. And if this is greater than 10%, just an if statement. Similarly for IRR equity, if the IRR equity is smaller than 10%, or if it is higher than 30%. And NOI year 11 is just a 0.12 here. Yeah, just a NOI in year 11. Exit cap rate is just the exit cap rate, same. So bring money or not, I assume it to be here like this. This one equals to if any of them is below 0. So if in this, let's call this whole thing as one sample, like as one iteration. So in one iteration, if ever there is a single year that you have to bring some money from your home, like your NOI is too low that cannot cover your bank promised payment, I will count the whole iteration as one. So you need to bring money. There are many different ways to assume this, but yeah, it doesn't matter, I think. So the probability would be, it's just average. And I know some of you also have similar issue. Yeah, you have some not like error numbers. It might be because some crazy number of exit cap rate. So what I do here is I use some called aggregate. Aggregate, this first one means I'm taking the average. 6 means ignore the error. And this one is just the data sample I'm working on. There are many other ways. I believe you might have better solutions. It doesn't matter. And here is also average. Yeah, I sometimes use aggregate. So because there might be some error. And here I also use average. So basically this, if it's all 0, 1, it tells you your probability. Well, if it's like numbers, it tells you the average. So what I find is the project level IRR is around 7%. Equity level IRR is around 13%. And the probability of loss is around 28%. And the probability lower than 5%, I mean, probability that asset level IRR is lower than 5% is 13%. Asset level IRR is higher than 10% is around 6%. And equity IRR is lower than 10% is around, the probability is 23% around. I know it depends on the simulation, but I've never seen my equity IRR greater than 30%. It's always 0 here. It's very robust. And the year 11 NOI is around 400,000. Exit cap rate is usually around 7%, and bring money or not is around 20%. So yeah, that's it. And something I find is, yeah, in the problem set, it asks you sample pro forma, which is what I already showed you in Excel, histogram of the distribution of NOI at year 11 and exit rate. I don't know why, but sometimes I see someone just report the histogram on exit cap rate or the NOI, not both. I don't know why you don't report both. And a histogram of the IRR of the project, which is many people do that. And I see someone only report the project level or the equity level IRR, not both, which is also weird for me. And what is the chance of IRR below or above 10%? Or like this one, equity IRR below 10% or above 30%? I mean, for this kind of what is the chance question, what is the chance? What is the chance? What is the likelihood? What is the chance? Most of time, I see people report a specific number as here, like the chance is 13%. The chance is 23%. But from time to time, I see in the answer saying, oh, there is a very little chance, there's a very high chance. So this is not an answer. Very little or very high is a very subjective statement. If you report like likelihood after you do some like pro forma or simulation or like modeling, you should report a specific number rather than those vague English terms. I think I've covered everything. What is the likelihood that you need to bring money, and what is the chance that you sell the property in a loss? And that's it. That's all for the discussion. So let me know if you have further questions. Have a good weekend.